Hey, what's shaking, lads and ladies? Brad the Guitarologist here. In this video, we're going to put a new output transformer in this Blues Custom 30 Epiphone amp. I've already changed the power transformer to a Mercury. I will put a link up here if you want to go see that video. It's going to be much longer than this one will end up being. This is going to be probably a pretty short video. The reason is I just want to put this up as a reference in case anyone else out there wants to upgrade your Blues Custom 30. I will show you what transformer I'm putting in here. This is the transformer. So this is a Hammond. I put a Mercury in for the power transformer, but this is a little bit of a cheaper option with going with the Hammond. I say a little bit cheaper. It wasn't that much cheaper. Probably, I think it was about 180 bucks or something, I think. After installation, I'd have to look back at the invoice, but it's, I mean, this is, you know, a pretty big expense to put this in there. But if you have one of these amps and you want to upgrade the output transformer, I highly recommend doing so. And this is the model that I have chosen here, and I think this is going to be a good one for this particular amp. This is a 1650 HA. It's a 40 watt output transformer, which is a little bit higher than we need. We probably could have gotten away with like a 30 watt since this thing is, it claims to be rated at 30 watts. Probably could have gotten away with that just fine, but we went with a 40 watt transformer. Let's see. Oh, this also has screen taps, which we will not need because this is not a linear, it's not an ultra linear setup on this. But if you did go with this transformer, you would have also the option of going ultra linear. First, let's clip out the leads of the old one, get the old one out of there, and then we'll figure out what we have to do to modify it for mounting. So just like I did with the power transformer on this thing, I'm just going to clip off a tiny portion of the leads here because I want to know what color went to which one. Okay, so one of them is going over here to the high tension fuse. So we'll have to cut this. Just a little bit of shrink tubing here covering this off. First of all, how long are these leads? I'm not even sure. We might have to, we actually might have to do a splice here anyway because I'm not sure that the lead length is going to allow us to go all the way with just the leads provided. Yeah, instead of splicing on new wires for the primary, I think I'm just going to cut these wires right in here and do the splice right in this area. Okay, so you can see here I'm drilling some different holes in the chassis over here because these two transformers are different profiles. They're not that far off in size, although the Hammond is slightly smaller. You can see that it's actually tilted sideways. If you, it's thicker. The Hammond is much thicker, but it's a little bit different dimensions, but it's tilted. You can see it's tilted sideways. It stands up higher, taller, in other words, than this one. This is kind of short and squat, short and fat, and this one is a little bit taller. So it's a different profile. It is going to work for us electronically, but we're having to drill a couple of additional holes. Plus, the other thing about this Hammond that I don't like actually is that the bell ends where the wires come out, they didn't really square this off and have the wires come out up off the chassis. They come out right down here directly on the chassis, so I'm having to drill a hole where the wires pass through so that it goes directly in. With this one, the other one, there's a little bit of play, so it comes out of the bell and you can, you know, angle the wires and go to the side a little bit and go through the hole if you wanted to. But this one's going to have to be pretty much spot on, so I had to drill a couple of extra holes in addition to a couple of holes for the feet. So that's what we're doing right now, but you can see the difference, like I said, in size on those two. Yeah, you like my Happy Apple back there? That Happy Apple is actually, that's something that I've had since I was probably 2 or 3 years old. And it's kind of followed me to every house I've ever lived in. You know, I took it with me when I moved out of my mom's house originally when I was in my late teens. And it kind of was just always there. You know, you'd have a house full of people partying or whatever, playing video games, and the Happy Apple would always be around. Somebody inevitably would play with the thing. But there's my Happy Apple. Makes me happy anyway. Oh, the other thing too, these holes in the center where the wires are going to pass through have to be they're going to be a little bit larger, and they're going to pass pretty close to the edge of the output board, so I'm going to have to pull this output board off and drop it down so that it's out of the way for whenever we drill these holes. The pilot holes, they pass through just fine without having to move it, but I think when I start drilling with the Christmas tree bits, it's definitely going to clip the edge of that board, and that's something we definitely don't need. Okay, these boards have a bunch of washers. There's 2 washers per input. That's because they're being also used as spacers, these little red spacer washers. I think that's gonna about get it. I think I want to do 1 step up on this. 2 maybe, or 3. Yeah, 1 more. Shit, 1 more? Really? Okay. There we go. Now then. Alright, so there are our holes. I'm going to clean up this mess. I got to vacuum all this crap up. While I'm up here on the bench, I'll show you this. Ron Fantano sent a little note. Hey Brad, hope these can help out. He sent me some Grover tuners the other day. I just wanted to say thanks to Ron. I don't know if I ever got around to saying thanks on a video for these, but I appreciate that, Ron. Those are going to go in my parts stash. Sucked up a screwdriver, sucked up my glasses. This is a pretty powerful vacuum. I found this vacuum in the garbage and refurbished it. Gave it new belts, cleaned it all out, took the roller brushes. One of the roller brushes needed a bearing on one side, replaced the bearing, and it works. It's perfect, man. Just as good as new. Okay, we're gonna see now how we did with our fit. I mean, I'm pretty confident it's going to be fine. So the side with the 4 wires, even though they're different colors than the original colors of the original transformer, these are very thick. These are super thick, actually. I think I want the smallest side to be on the outside. So looks like, yeah, they have a real big side, they have a small side. Well, the underside's got a little bit of some burrs there, so we're gonna have to take care of that. This is always one of the hardest things to do. Get a grommet in. That it? I think that's it. There we go. Now then. Now it's in there. Okay. So there's the grommets. Those are designed just so that over time the wires don't rub against the chassis and you know, short out to the chassis wearing the insulation out, that at least there's some kind of spacer there to ensure that doesn't happen. I don't think it's really necessary in most amps. I mean, unless, because it's not like you're getting in there wiggling it around. It's just an added safety measure, so why not put them in? I'm just hoping they don't stick up too tall on the other side. Okay. Yeah, I think it's rocking a little bit, but I don't think that's going to be a factor. Okay, so the old transformer, the wires on here were, let's see, that one is the 0 ohms, and then it skips over here to the 4. So that's the 0, 4, 8, and 16 is right here next to the 0. On the new transformer, the colors are different, but it's just, okay, black is still 0, but let's see, it goes, green is 4 ohms, so the green will come there. Yellow is 8 ohms, so it'll be green, yellow, white. Okay, this will give us a chance to see the these new wire strippers that a viewer got me in action. So basically, you just choose which slot you want the wire to go in. Right there, you see the different slots, the different teeth. So I'm going to choose this one. That's about the closest to the correct gauge of wire. So I put it in there, lay it in, and basically just squeeze, and it does the whole thing, and then it releases, and then it releases the rest. Really, really, really fun to use. I've never said that before in my life, that stripping wires was fun. But when you're doing a bunch of them, and you do it like this, man, it sure makes a huge difference in the speed that you could do it at. I mean, if I knew the length of these, I could knock all these out too right here. But we're going to figure out which wires which on these. We're going to cut and cap the 2 wires that are for screens. If we wanted to install this transformer in an amp with ultralinear capability, we would have the ability to do that. So these 2 right here are the screens we will not need, so we will just cut and cap those essentially. Cut them down here low, and then we'll cap them off with a couple of pieces of shrink tubing. There we go. Now those won't get in anybody's way or shock anybody if they're back in here with it on. All right, I've got a speaker set up over here off camera. We're going to dial it up on the Variac and see what we get out of it. Probably would help if I got a power cord. All right, let's put it on. Dial her up. Get relays. There's 100 volts. And we have an amp. All right, I'm going to dial it all the way up. I want to see what the overall current and watts draw is for this thing when it's all the way up. It looks like it might be a bit high. Uh, 1 amp about, and 106 watts. So that's telling me possibly we might want to rebias this thing. I'll have to look at my I'll have to look back at my other video to see what the overall power draw was. That 106 kind of concerns me, and the 1.06 amps overall kind of concerns me. What I want to do is probably bias this thing so that it is close to where it was before and just kind of leave it at that. But let me double check where that was originally. If it's within 5 watts or so overall, that's not going to be of really any concern. The main thing we have to worry about with power overall was, I mean, the power transformer was the big deal there. The output transformer, if there's a slight difference in turns ratios, it may affect the bias on the output slightly. You know, if there's a higher DC resistance in the primaries windings, then it's possible that it may affect that ever so slightly, but it doesn't look to me like it's excessive right now. So, okay, so yeah, I'm kind of looking back over my video now, and that's the cool thing about making videos, is sometimes you can see what the state of an amp when, you know, you were videoing it last, and that's always nice. But anyway, in this clip in the video, I didn't get all the way up to 120, but I did get up as far as 105. And it looks like at that point it was drawing about 860 or so milliamps. And at that same voltage, right now I'm drawing 930 milliamps. So we're within a tolerance there that's not bothering me. And the wattage was 77 watts at this point in the old clip. And right now it's at 82.9, 83, we'll say, watts. So we're within 6 watts or so overall, and that's, you know, again, that's spread between everything in the amp, you know, that is dissipating heat. So it's not excessive to the point where this concerns me at all. So I think we're pretty good with this. We can see that the hottest thing in the amp is the bias resistor back there, which is what we expect anyway. This is a cathode biased amp, and it's a cathode, and that's a 25 watt resistor. So you can see right there that it's rated for 25 watts. So it's probably dissipating, I'm guessing, somewhere around, you know, maybe 20 watts or something like that, 15 to 20. So they would have overrated that, and it's, you know, dissipating everything for 2 tubes, 2 5881s in fact, in push-pull. So that's why it's getting so hot. If we look around, some other things that are getting warmer, it looks like that capacitor right there. It looks like maybe that's the bias cap, getting a little bit warm. And actually, I'm kind of wondering whether or not I might even be looking at that resistor back there, the screen resistor, possibly. Yeah, I think that's what I was looking at for sure, is the screen resistor. The bias resistor, that's getting up to about 62 degrees Celsius. That's a tube heating up the board. That's a tube heating up the board. You can see what I mean. Look here. You know, that's getting up on 40 degrees Celsius right there at that spot where the tube socket is coming up through the board. Over here on V1, there's another tube socket. You know, and look at the output. Let's look at the output tubes. That might have even been what we were looking at before. That is what we were looking at before. So that's the output tube sockets from the underneath, from the underside. Now those probably have a little bit more space because they are a bigger socket, and the socket itself is ceramic, and it should dissipate a little bit more heat, just the socket, before it gets to the board, which is helpful, but it's still not gonna, see, the wires are kind of in the way of getting a clear picture there, but you can at least see that those sockets are heating up that board, and they're heating it up pretty considerably. That's the rectifier right there. That's the board right by the rectifier. And yeah, that's the one drawback that I see with a design like this. Like I said in my last video, but this is not nearly as egregious as some other amp models and manufacturers that I've seen. I mean, there are some that are just, you know, where they've got ICs on the same boards as tubes and they're pretty close proximity, and you just don't want that kind of stuff, man. You know, you're going to end up just screwing something up because of all the heat. And if the board material itself has enough impurities in it, over time it can become conductive because of all that heat and cause major problems. And it's problems to the extent sometimes where you have to replace a board, and if it's in an amp that's been discontinued and the manufacturer no longer even supports, then you're truly screwed, and it just becomes landfill at that point. And you've lost, you know, all of that money. And I'm just one of these people. I'd much rather get an old Marshall, an old Fender, or an old Gibson amp or Ampeg or something, you know, from the 70s and before, that's point to point, or put on turret boards or eyelet boards, or, you know, hand wired in some way so that you can change discrete components and everything's built out much better. But anyway, that's just me ranting. All right, so just for giggles here, open up the old transformer, took the bell ends off, and this is excavating down inside of it just to kind of see if we can get an idea of what might have happened. We've had some melting going on, so definitely this thing had gotten hot inside to the point where there was some melting of this this plastic tape here. Here's the other side. There's a thicker plastic cover here that sits over the top of this. There's another layer of tape. This all was kind of down in this manner like that. So we've excavated down to the point where these wires are all hooking up. You can see how they've done this. So the leads that are coming into the transformer hook up to the windings right here and are soldered on and then bent over, and a layer of tape onto a layer of tape. If you look at it from the other side, I mean, you can kind of see where, you know, some things might have a tendency to arc if one isn't careful here, because we've got a lot of open leads just in real close proximity to one another, and, you know, some of these are pretty high voltage, so you can see where that may happen at times inside of a transformer like this. I mean, you've got different windings here that are really close proximity to exposed wire, exposed solder joints. I'm not saying that this was the problem over on this side. I think more likely the primary may have been the culprit, just simply because of the melting that we're seeing over here on this winding. Or at least it looks to me like it's been subject to some melting. See this, all this right here, that's melted material. It's melted plastic. Right there, and a lot of this here is melted. Now that could have just been in the course of normal operation as well. I definitely don't see anything burned. But this thing certainly was in the process of failing, and my hunch is that there was if we were to excavate deep enough down inside of this, we would probably find, now we're getting some blackness right in there, looks like maybe. But if we were to excavate far enough down into this, I'm suspecting we would probably end up seeing just a shorted turn somewhere. That was the source of the problem. I mean, this is we're not even anywhere near being down inside of this thing. If we wanted to get further down inside of it, we would have to delaminate all these laminations here, which I kind of started doing. And if you wanted to, you could excavate this out of here by taking all these laminations off of the transformer. Like, for instance, the one on this side would probably be kind of hard because it goes down the center. I think if you got one of them off, they would start coming, but I really don't I need a thinner tool. I need what I need is a I need a disposable razor blade to get, yeah, to just kind of get under there. I can get my fingernail under that one, but I'm not going to push my luck with that. But essentially what this does, one of these is shaped like a T, a big T that goes through the center. And then this one kind of goes around the outside. It also goes to the center, and then they alternate for each layer down. So that's how the stack is put together. And without delaminating all that and taking all that apart, it'd be hard to really excavate down on these windings. But I just kind of wanted to see, at least on the outside windings here, what it looks like. Somebody commented on the video. I just saw it a little bit ago, the original video. Commented that obviously they said the standby switch was the problem. It was shorted. Well, that's what a standby switch does. A standby switch is short. That's what a switch does. But it wasn't shorting the ground. It was, I don't know what he was talking about, but he was trying to say that this transformer was not the problem, and it clearly was the problem, as when I replaced the transformer, it fixed the problem. So and once again, you know, okay, there's even more connections here. I mean, obviously there's going to be a connection for each one of these wires that comes in for these windings, but you can see how close a lot of these leads are right in here, and you can, I'm sure, see the potential here for arcing inside of a transformer like this, particularly if you have any adhesive or other material that becomes even slightly conductive over time. It will have more of a tendency to arc between these points. Yeah, I don't see anything obviously burned here, which I didn't really expect to see. I think the problem, I mean, usually on transformers, the problem is it has to do with the lacquer coating they put on the wire itself eventually breaks down, and you have windings that end up shorting across onto either another winding or another part of the same winding. Those might be thermal fuses. Yeah, it's a thermal cutout. Has a PBT resin case with epoxy sealing, automatic reset, moisture and dust proof. Okay, it's a thermal switch. So if it gets too hot, it will cut itself off. So if this thing really was going up in flames, at least it does have that thermal switch. Now it wasn't getting hot enough quite to go up in flames because it had the protection of the fuse. If someone were to stick a fuse in the amp that was too large, then these would kick off. So these would switch and break contact, and that would you would have to actually reset. You would have to take power off of it in order to reset these and let them cool down, and then they would allow it to function again, or try to function again after you had fixed the problem. But that just prevents some idiot from putting a huge fuse in an amp and then burning the house down. So that's nice that they did that. The problem is, like I said, somewhere inside of this transformer, there definitely is a shorted turn, and I'm certain that was the source of our problem. But the thing is, the fuse was blowing before the transformer was actually, catching fire. So without doing what someone had suggested and like putting a piece of copper tubing or something inside of the fuse and then seeing what burns, you would never know, you know, what exactly the problem was inside of the transformer. Then you could excavate down like I'm doing here, and you could probably find, maybe even find the point of the burn. But anyway, there's that. That was fun for a minute. So that'll do it for this video. I hope you've enjoyed it. If you have, hit subscribe, and we will see y'all later.